All right, good. All right, well, good afternoon, everyone, and sorry for the delayed start. I guess it's the first session experience. So I'm going to talk today about System Ready IR and this little experiment that I conducted of the System Ready IR just work. A little bit of introduction. So my name is John Humphreys. I work for Texas Instruments. I've worked for TI for a number of years and done a whole lot of different things. My current role right now is I lead the OSPT team. This is open source product technology. Our goal is to make sure that TI is plugged into the right ecosystems, the right communities, that we're engaged in the right open source projects that make sense for us. And so that's kind of our goal there. A little bit about TI, who I work for. So TI's had a long history of being engaged in open source and in the community, and we've been working for a number of years on really trying to instill, most importantly, what we call an upstream first culture. What that means is not only do we want to contribute back to the community, but when we work with the community, we want to target that first and then backport to our product second. So that's the culture, the mindset, the mentality that we strive for within TI. Okay, I'm going to give you guys a really fast introduction to Project Cassini and System Ready IR, just so that everyone is kind of understands where we're coming from. But Project Cassini is kind of this umbrella project. It's really aimed at addressing the fragmentation in the ARM ecosystem and really looking at how can we standardize and have everyone do things in common ways so that we're more interoperable and kind of think of it more of like we get the Legos model, right, where the pieces kind of interact and it's not all these isolated ecosystems here. So it's divided into to System Ready IR, which is what we'll talk about today, and that's kind of the foundation of the contract between the hardware and the software that allows a lot of interoperability. But just for context, Project Cassini also includes Parsec, which is really trying to standardize the security APIs so that it's easier to have applications move across different devices and not have to really dive down into the weeds to adjust for the security components. And then the last component here of Project Cassini is the cloud native stacks, and that's really bringing all the goodness that the modern DevOps has brought into the embedded ecosystem. Okay, and then of course the goal of all this is that it just works, and so that's really the talk of this presentation here. So how does System Ready tackle the fragmentation? So in the past, obviously every hardware vendor had their own hardware. Because of that, then they also had their own firmware, and because the firmware is so closely tied to the OS, they really had their own fork of the OS, distribution of OS, or the SDK here was their own, and so the applications were less portable, right? So what is System Ready trying to do? Well, obviously the hardware vendors are going to have their own hardware. That's not going to change, right? But if we can have rules around that hardware such that it's easier to enforce some standardization, then that is done here. That makes it possible to have standards around the firmware, and what we're really shooting for here is to really have this define this API between the OS and the firmware. Okay, so that the firmware presents to the operating system or the system software a standard view of the hardware, and the OS has an API that it can rely upon. And that's really the key to System Ready and addressing the interoperability is defining the standard right here that OSs can rely on. Because once we have a standard that an OS can rely upon, the OS no longer needs to be specific to the firmware and to the hardware. Okay, so that's the key. So System Ready is addressing a large market, and there are different bands of System Ready. For this talk, I'm specifically focused on IR, which is the embedded. You also have things like Server Ready. I think that stands for the server market. But I'm just looking at the IR band of System Ready, and this is particularly UEFI plus device tree is the predominant discriminator for for the IR band. And just so that you have the context of the standards, here are the relevant standards here. So you have the BSA, which is kind of the hardware requirements, the BBR, which is the firmware requirements running on that hardware, and the presentation that it's required to present to the operating system. EBBR is kind of a market-specific supplement for system-ready IR. And then we also have security requirements. So these are the main standards that surround this work. Okay, so for me to really be able to evaluate if system-ready IR just works, we kind of need to have a definition of what just works is, because that can be very can vary from person to person. And the reason is because just works is not a requirement, it's not a list of specifications, it's an experience, right? I mean, when you've worked with something and it just works, that was an experience that you had. And certainly when you worked with something and it didn't work, that was an experience that you had, right? It was, experience of this is a piece of junk and I don't want to ever touch this thing again, right? So the difficulty here is it just works as an experience, but I still need to kind of define that. But it reminds me of this story on the experience of the operating system team that wanted to make an OS installer just work. I mean, they didn't use that terminology, but they wanted to make it so that it was super easy and that their grandmother can install this operating system. So they did everything and boiled it down to all you had to do was press any key on the keyboard, right? And so they just knew that the support forms would be blank. There would be no discussion because it just was easy. I mean, how could you not be able to do that one step, right? Well, they got all these support form questions about, we can't find the any key on the keyboard. So, so the whole experience of just works, it's something that varies, and so it's kind of important that we try to level set what we mean by it. So here's my attempt of a definition for this talk. So just works is an ecosystem of components. So it's a lot of components that interop together that can be installed and correctly function together out of the box, okay? And this is without any customization or modification of the software, okay? Because if you have to customize or modify the software, it's not out of the box, okay? It doesn't require expert knowledge. So if you have to really understand about device trees, about RPMBs, about ESP partitions, things like that, then there's the just in just works is gone, in my definition at least. And then the third is it can't be device specific. And this is much less about the experience than it is about practicality and economies of scale. If we want OS vendors and other ecosystem partners to be able to just work on all devices, they don't have the resources to build device-specific solutions, right? So it's really important that you have this device agnostic nature for it just works to be realized. So this is my working definition of just works. With this, we have a high degree of interoperability and compatibility, and experience is easy, and that's what we're shooting for. Okay, so I had this grand ideas of all these different kinds of tests to see if it just worked. The first being that I just wanted to boot a generic image of a standard distribution. Well, this is all I did for this presentation. So this is as far as I got. But I wanted it to be a just work. So without modification, without being an expert. Obviously, it's a generic image, so it's not device specific already. And I ran these on any system ready IR certified board I get my hands on. But I'm not going to. I don't want this talk to be about the vendors, but about the standards and how we're doing. So everything's anonymous in what I talk about going forward here. Okay, so the first test was just, again, booting a generic distribution. So what are the things that I found that spoiled just works for me, at least for me, okay? So the number one problem I ran into is that the boards that are certified against a system-ready IR, obviously you need to You need to set what board version you're running on, as well as what firmware version. That just makes sense because that's the configuration that the certification applies to, right? So I understand that, okay? But the problem here is that when I get a board, I don't know what's on it, okay? And so I now need to go look at the certification report and find out what version of firmware was used to certify it, and then go find that version, okay? And good luck with that, because the certification reports will say, you know, that it's based on U-boot 2021.04 and then some get described string. I can't find it anywhere. And even if I did find it, now I got to build the firmware, which I didn't really want to do, because that's not just works, right? So that was a bit frustrating, as it was very hard to reproduce the exact configuration that was claimed to be certified. Now, it would be much nicer if I could assume that if it was certified on version, you know, 2.0, and I'm running on a version 5.7, that I can just use the 5.7, because that also must work as well. But that also wasn't the case. It wasn't also true that if you get a later version, that it would just work, unfortunately. Okay, so so what are my recommendations here? Sorry.
Sorry to interrupt. I just have to leave. So you're right about the recertification and not being able to download a newer version. Enough of the boards in the certification page, you can download the precompiled binary. I don't know if it's on all of them. Vincent can answer that. But as far as U-boot is concerned, before every release, we do try to run the ACS and make sure that we don't break it across releases, right? So if you download the stable release from U-boot, and apart from, I think we broke it inadvertently 2023-07, and it was just one test breaking. There was no functional breakage. Other than that, U-boot generally on stable releases can produce system-ready compliant firmwares.
From 2.0, so we are requesting.
All right, thank you. So many boards did have links where I could download the firmware, and for those boards I could get past this first step, but for the many other boards I couldn't, and so I was stuck at this point here. So the recommendation I have here, so Ilias mentioned that let's, you know, make sure that the later U-boots are compliant. And this, by the way, is my plug for the One Labs that we'll hear about more, because that to me is addressing exactly this issue, so that you know you can go to a canonical place and say, okay, I know this is the latest version and it's good to go for system-ready IR. But I think that the recommendations I have here are equally very important, very valid. So in my opinion, to address this, we should require that development boards are shipped with system-ready IR compliant firmware out of the factory, okay? And if the version of the firmware on that board is different, it's only different because it's been updated through a system-ready IR method of updating, which is the UEFI capsule updates, right? And here's the kicker that is my recommendation for system-ready IR certification. It should require that the certification be run on the board, either untouched from the factory, so running on the firmware that's already on that board, or has only been updated through the capsule update mechanism. Okay, all right, so the next thing I ran into that kind of spoiled the JustWorks experience was that in the certification reports, there was errata. And I get that erratas are necessary, because things happen, right? So erratas around, well, use this brand of power supply, not this other brand, because our board doesn't work well with it. Great. Corner cases, I'm booting from UART, and if you do that, you can't access, this I2C bus or whatever. Fine, But the issue I ran into here is that the most boards had an errata document that you had to follow just to get the system ready experience to happen. It wasn't a corner case, so you had to do that every time, and often the errata was not simple. Okay, and so it involved obviously the flashing the firmware that we kind of mentioned on the prior one, but having to format the storage, having to reset your RPMB, having to create an ESP partition, other things that were called out there quickly became very complicated, and and really just fails the just works test, in my opinion. If you've got to follow these errata for your normal case, okay. And then sometimes they involve using scripts that there were links to the script that were broken. I couldn't get to the script, so I could never go beyond following the errata to get it to work. Okay, so what's my recommendation here to improve this? Obviously, we talked about pre-installed firmware prior. Having the storage pre-formatted. I don't understand why the ESP partition isn't created by the OS installer, why that's a requirement in the errata, but it seems to me that that should be the OS installer's job. And then last and probably most importantly is that if you do have scripts or things that you have to run to get it to work, that should be part of the artifacts that are archived with the certification. So there's some way that you have access to this. So I can see there's already questions, so go ahead.
I'll make a comment on the ESP creation one. The desire, the intent was not to have that for ESP, the OS installer, be completely able to do that. The challenges with these initial boards that we're doing, whenever we've got a board that needs its firmware on the ESP in order to get to system ready and then boot the OS, we've got this chicken and egg problem, and it's not good, and it's not what we want to do. Good, well-designed boards should not have their firmware in the ESP so that the OS can do exactly what you say. So this is a bug, and this is that particular one is definitely growing pains that we need to move away from.
Okay, good to hear. Okay, all right. So the last, So the goal really, I think, for this is that we should have no errata. I mean, that really should, for just works means no errata, in my opinion. Okay. All right. Okay, so this is the fun one that I want to talk about. So this is the need for the OS to be able to have the option to provide a device tree if it cares about a particular version device tree. So let me see if I can describe this very quickly. But so an OS needs to know what firmware it's running on. So, and how does it know what hardware it's running on? Well, it determines that because through a device tree, which is a description of the hardware, supposedly. So I'll get to that in just a second. So with it being a description of the hardware, it makes complete sense that the firmware is the person or the piece that presents that red line that I showed earlier, presents a common way of describing the hardware the OS is running on. So that makes complete sense. And if the world were ideal like that, that is a very clean solution. Love it. Okay. But there are, and therefore the EBBR does require that the firmware supply the device tree. Okay, that's part of the spec. Okay, the reality of the situation though is this: so the device tree isn't really a description of the hardware. It's actually an abstraction of the hardware created by OS drivers to present the particular information about the hardware the driver cares about in a way that the driver wants to see it. Okay, and because the driver then decides and dictates what that abstraction is, because this is for its convenience, that abstraction will evolve over time. Okay, which means the device tree description is going to evolve over time. And I do want to call out, device tree maintainers spend a lot of effort, a lot of work to ensure backwards compatibility so that you can boot newer OSs with older device trees, and they're doing a great job with that to mitigate this problem, but it doesn't remove the problem. Okay, so that's problem number one. But there are also some other practical aspects that cause there to be a need for the particular OS to want a particular version of device tree. So the other issues you run into are bugs. There are going to be bugs in your device tree description, and if the particular OS cares about that bug fix, it's going to want to say, I want this version of the device tree. Okay, so that's one issue. The other issue is that often the features on a device are not all present on day one. So there's this incremental release of features over time. And so as those features get added, maybe support for, I don't know, some display modes or things like that, you need to add it to the device tree. So the device tree is going to evolve, and the features that the OS may care about will require it to mandate a particular version of the device tree. The last version or reason that I think is probably not spoken much about is that if a vendor, if a OEM really cares about the stability guarantees that an OS provider is giving it, then oftentimes the OS vendor is going to have validated their operating system against a particular configuration, a particular device tree, and those OEMs are going to care that they use that version of device tree that has been validated and has that guarantees from the OS vendor. So there are reasons why the OS may want to dictate a particular version of the device tree, and so this does become an issue. So the possible solutions to this problem, I think, are a talk in and of itself. There's a lot of discussion about that. So one option that I hear a lot is, let's don't do anything because it'll mature. This problem will go away over time. And, you know, I mean, I get that on platforms as they stabilize, but I don't believe it's ever going to go away. And certainly you also have the issue of new platforms coming on board, and that whole growing pain process is difficult, and you want some mechanisms to be able to survive through those growing pains. There are other ideas like having the OS provide a capsule update, so that way it can you can tell the firmware, hey, let's make sure we're at least running this version of the device tree. That has issues too, because today you need the entire firmware. You can't just have a capsule just for the device tree itself. But even if we did, then we also run into issues of if the OS wants a particular device tree and you're running on a secure platform, well, that capsule needs to be signed with the firmware keys, not the OS keys. And so you run some logistics like that. Hold on.
If the OS wants a specific device tree, it's not system ready anyway, so you have numerous other problems that are already coming into play.
Okay, that comment came from Peter at Red Hat, so just want that noted. All right, so other solutions, UKI, it's a nice packaging, but that I think is even the wrong direction, because that's even more device specific. There's some ideas around, so the firmware knows what device tree it wants to use. The OS knows what device tree version it wants to use. So some ideas around separating those two. The firmware decides what device tree to use, passes that to the OS loader. The OS loader says, okay, well, I know where to find this device tree name. So there's a lot of debate around that, although there's still complications with that as well, particularly when you have device tree overlays, make that very complicated. So this right now is a very open debate right now on how we solve this problem, but I'm glad to at least hear that there's recognition that it is a problem, which is step one. Okay, those are the findings I wanted to go over. I do want to make sure that the takeaway from this talk is what I want it to be. So I've gone through this experiment of does system ready IR just works, and in my opinion, with this experience, it was not a just works experience. So it failed in that respect. But I don't want the takeaway to be that system ready IR is a failure, because I very much believe in it. It's a very noble endeavor that is really important for our ecosystem, and I think this is the right direction to go. You look at how Windows and Intel have tried to standardize on this to handle lots of different boards, right? Well, we're in a situation where it's not just one silicon vendor, it's many silicon vendors. It's not just one OS, it's many OSs. And of course, there are many board vendors in between. So it's a much harder problem. It won't be perfect. We won't get it right the first time, and probably the 10th time it still won't be right. But I think that our pursuit of this goal is very, very important. So I hope my takeaway from this talk is here's some issues. Let's address them, and let's keep our eyes on the ball of really reaching system ready IR, the goal of system ready IR, which is just works. So, all right, questions?
Yes. Hi. So so I'm Pedro Garcia, as you know. So I'm owning the system ready IR. So that's good. Initially, when I saw the presentation, it was a bit of a reaction, but it's someone else talking about system ready. from a different company. But actually, I think it's great, actually. So that's really good feedback, actually, yes, how we are doing things, actually, and how the things are being perceived. So which is, I do really appreciate, and actually it was really great, actually, and I think that it's a very healthy exercise. First things first is just works. So that's kind of a marketing cut, if you like. Actually, that's not, and as you said, that's an experience. And obviously, that's a long-term vision. So we are working towards that. And so I think it's not fair to say that if you are system ready certified, the expectations are you should just work. That's not what it is. Actually, we are working towards that. I think, and that's something I would like to make the focus, actually. So system ready is about changing the industry, or the IoT industry, if you like. And there's kind of a 30 years of legacy there. And actually changing 30 years of legacy within the IoT embedded industry is not simple. So changing the architectures, change by evolution, never by revolution. So then we are going kind of a step by step, little by little, and actually, and that's why, so we just started with IR 1.1.2, so then going to 2.0. And actually, I acknowledge all those things. Actually, it's not I'm denying them. So I truly acknowledge them. So we are working towards them. And actually, so that's why early on the coffee, I invited you to join the System RTC, the advisory committee, because that's the place where we create, we acknowledge, we say what are the priorities and what we should be doing next, actually. And I have to say that this is on our roadmap, and actually this is something we have to solve. So, but yes, I wanted to make that focus. So this is a journey, long-term journey. This is not going to happen overnight, actually, and this has to happen collectively. Actually, this is something that needs to happen among all of us.
Yes, and that's why I really reiterated the takeaway I wanted from this. Not that system ready is a failure, because it's not. This is a journey. Here are the gaps that I found, and I just want to call attention to. Let's make sure we stay focused on them. The Just Works is a marketing term. I get it, but it's an awesome goal for us to shoot for.
Oh yeah,
we won't
absolutely.
hit it, but shooting for that goal will be so much better off.
Yeah, I would say my takeaway, we fully agree on everything, actually. So we agree on the goals, actually, and on the journey.
Perfect. So I know I'm probably way over time. Are there any other burning questions before we close?
Okay. Yeah, we're over time.
Okay. All right. Thank you very much.
Thanks, John.